This is the topic 14 video. However, before you can do this, you need to be able to do these three. These are three questions that come from topic 13. So I would like you to take a quick second and find some free space on page 14 and answer these three questions. If you can't do them, that means that you're not ready for this topic, and so you need to either go back and practice more. Maybe you missed it, maybe you jammed through it, but it deserves review again. So here's the first answer. Force gravity, force equals mass times acceleration. So force gravity equals mass times acceleration due to gravity. In other words, force gravity, this is a special formula, equals m. We just, acceleration due to gravity, there's the bell again, is small g. So force gravity equals mass times 9.8. 2 times 9.8 equals 19.6 newtons. Alright, we have a small girl. I know the mass. Accelerates safely at 0.8 meters per second squared. Acceleration equals 0.8. Force is the question. My formula that has these threes is F. This is net force, by the way, but we'll talk about that more today. Equals mass 27.2 times 0.8 27.2 times 0.8 equals 21, what was that? 0.76 newtons. The net force acting on this one is stronger, winning. That means that's the winner. So the net force I know is in that direction. Because they're in opposite directions, they cancel each other out. So this is 15 minus 10 equals 5 newtons. So that was your review. You need to be able to do those. By the end of the day, you'll be able to use this formula when there are multiple forces in one dimension. That means left and right only, or up and down only. And they're on textbook pages 96 and 97. There's nothing new. That should be nothing. So the vocab we're going to use: applied force, net force, force of friction, drag, air resistance. We're going to use a lot of our forces today. And the topic is acceleration with multiple forces, page 17. So we'll ignore this for now. Oops, come here. We'll ignore this bottom part, but I would like you to do the top. So we're going to be solving for missing forces. When we know three things, we will know the various applied forces on an object, and we will also know the net force with the dotted line. The net force is usually drawn above or below an object. The applied forces are coming off the object. So let's think about this as winners and losers once again. So copy this little diagram. This is the winner. I know that because this is the net force, and the net force is pointing to the right. That means on the right side, it's stronger. Whatever force it is, it's stronger. And this is the loser. Had the net force been pointing in the other direction, that means this side would be stronger and this side is weaker. So winning equals stronger force. The losing side is a weaker force. Now, example 1 is solving for the missing force with a known loser. So let's see what I mean. So write example 1. This is an example, so it's highlighted in blue. So copy this down. I know you can pause this video at any time, by the way. I'm going to jam right through it on the recording because, well, you can stop me. This is 2 newtons. The net force is 10. That means that the difference between the winner and the loser is 10 newtons to the right. So question, how do I know this is the winner? The answer is the net force is always pointing in the direction of the winner. That's why the net force is that way. So the difference between these two is 10. One way to think of this, if it isn't apparent to you already, is loser plus win plus net. Oops, let me erase this. The loser plus the net force equals the winner. So that means 2 plus 10 equals 12 newtons. And that makes sense, right? The difference between these two is 10. This one's 10 stronger than that one. Remember, net force could also be written like this, the sum of forces, which is the same thing. You add these two together, we'll say right is positive and left is negative. 12 minus 2 is 10. Clear this up. Okay. Solving example number 2 is going to be 2 with a known winner. Here's your picture. This one now, it's backwards. This is the winner. I know it's the winner because the net force is pointing in the same direction. You can think of this with the difference between these two is 10, and this one's losing, so it's weaker. So we have winner minus net force equals loser. So this one is resisting by whatever would make this equal 10. So 20 minus 10 equals 10 newtons. So 10 of this cancels out, and you're left with only 10 in the net force direction. Now, questions like these will not be on the test. However, they will be just part of the question. You will need to be able to understand this in order to actually do the one test question that will be on this topic. So, copy these down. Do them kind of small. Should take up about 5 lines, and try to answer them. So pause the video. It's very important, by the way, that you try these. So don't just zone out right now. You need to try these because I would say this is the easier part of the topic 14 question. It's like the base. You need to be able to do this to do the next part. So pause, draw these small, and try to solve for the missing force in each one. Remember, how do you know if it's the winner or the loser? And then maybe use your little formulas or do it in your head. Here come the answers. In this one, this is the winner. So I know that winner minus net equals loser. 25 minus 15 equals 10. So the difference between these two, 25, it's only 15 stronger than this one. So 25 minus 15. This one is the loser because the net force is pointing in the opposite direction. So this one over here is 5 stronger than that one. So 7 newtons is 5 stronger. Same with over here. This is a loser. This side is 10 newtons stronger than this side. Loser plus F net equals. What's 10 stronger than 5? 15 newtons. 5 plus 10. Okay, this is, we need to find the loser. This is the winner because the net force is in the same direction. So this one is 20 weaker than this. Winner minus net. So 50 minus 20 equals 30. And now if you look at them, the difference between these two is 5 down. The difference between these two is 15 to the right. The difference between these two is 10 left. The difference between these two, 30 and 50, is 20 to the right. Okay, now this is what the test is. That's it. That's the only thing new is what I just showed you. Everything else is going to be exactly the same as it was in the first topic, only you have to think a little bit more. Because you have to figure out, am I solving for the winner or the loser? So here we go. Pause the video and see if you can solve this. First thing I want you to do is draw it. So pause the video and try to draw it. Here's the answer. 2 girls fight over a backpack that's 5 kilograms. One girl pulls to the right with 15 newtons. If the bear accelerates, so I know mass equals 5. Acceleration equals 2 meters per second squared. What's the force by the girl on the left? Okay. Who's winning? That's the first thing you need to know. Who is winning? Here's your hint. The bear accelerates to the left with a, so I know that the acceleration is that way, which also means net force is that way. And I can solve for the net force with mass times acceleration. 5 times 2, 10 newtons. So now I take this up here and I put 10 newtons. And now we're back to the examples that we just did. So I know that this one over here is 10 newtons stronger than this one. What's 10 stronger than 15? 25 newtons, and that's your answer. 25 newtons to the left. Draw the picture, find the net force, and then do the problem like this, is how it's going to break down. So I walked you through that one. So, draw this one. There's a trick here. Can you spot it? Skydiver with a mass of 100 kilograms, accelerating upwards. So that's the direction of our net force. Acceleration equals 2 meters per second squared. What's the force of air resistance? I know mass is 100 kilograms. Okay, it didn't give me the, I need to know this. He's falling down. Force gravity. I need to find force air. Can you do it from here? See if you can try it. Here's your answer. I need to find this first. Mass times g. 100 times 9.8. 980 newtons. I also know that the net force equals mass times acceleration. 100 times 2. 200 newtons. So I know this right here is 200 newtons. This one here is 980. And this is our winner. This one is 200 stronger than this one. So what's 200 stronger than 980? 1180 newtons. Is his parachute open or closed? How do you know? The parachute is stronger because he's accelerating upward. Sorry, the parachute is open because he was in free fall, but the parachute opened and now it's jerked him upwards as he's coming to a near floating stop. So that's why this force is so much bigger, because the parachute is opened. And it's way stronger than gravity now, which is why you start gently falling. Okay, if you need to, pause these and back up and listen to it again. Okay, I want you to do this one on your own first. Start to finish. Start to finish. Here's the answer. 200 grams. Mass equals 200 grams. Convert that to kilograms. 1, 2, 3. 2 kilograms. Applied force of 50 newtons, and we'll call this to the left. It accelerates. Oh man, I made this hard for you guys. I'm sorry. You're not able to solve this one until now. 20 meters per second left. So I know that my net force is also this way. Acceleration equals 20 meters per second squared. What is the magnitude and direction of the force of friction slowing the wagon down? So friction opposes motion. First thing I need to do is find the net force. F net equals ma, or the sum of forces, equals 2 times 20 equals 40 newtons. So this is 40. Force of friction is slowing it down. So the force of friction is 40 weaker than 50. So the difference between the two is 40. So it's 40 weaker than 50. Winner minus net equals loser. 10 newtons. Alright, that's it. At the bottom of the blog, there is one question that I want you to submit to me, and then there'll be an assignment listed below from the textbook.